welcome back to my shed. Yeah, quite a lot's happened, and I've been a bit lazy with me filming, but such is life. So where do we get to? I think the last videos I was boring out some barrels to make me 300cc. This is an old KR1 barrel, which is obviously a bit scrap, but that's the one I used to set me fixture up on. So yeah, so I bored some barrels out. Most boring video ever. Anyway, but what that showed me was that we had to change the ports, because once you come out you change the ports slightly. So mainly, if you can have a look in the back of here, and I'll get my pointing finger out. On the standard barrel, that's your boost port at the back, which is in line with your transfers, which come up from the sides. Alright, so now if you make the bore bigger, what it does is it drops that port down because it's slanting like that. So what I had to do is I had to pester my mate Andy, who's a top bloke, into lending me his like holy grail of porting tools. So Andy, who's a top banana, he lent me two things. He lent me this and all of his other porting gear, but what he also lent me was his secret little black book with all the dimensions in, all the secret dimensions. Not that I need any of that, because I'm not tuning this. I keep saying I'm not tuning it. Well, I probably will, but I'm not tuning it anyway. So what I had to do with the barrels is I practice on this one because it's a scrap barrel. But basically what I had to do, you can get a nice shot of this because I've removed the web out of it. But we had to use this burr like that, obviously with it running, but we had to bring that port right back up to here and keep that angle on the back, on the boost port side. So this was just me getting a bit of practice in on a scrap barrel. There's also another little trick that he showed me to do with the rear transfer port as well. The great thing about this setup is it's not air driven, it's electrically driven, so this is really powerful. It doesn't stall on you, it's the best thing in the world. I modified the ports, I've done a bit of radius in, not too mad, just took the edges off the ports and sent me barrels away. So I shipped them off in a box, hopefully to be plated. So I do have the barrels back now, so you can have a look at them. So going on their advice of leaving X amount on for their plating thickness and to be homed to size, this is how they've come back. So all the ports are lovely and radiused, done a cracking job of the plating. It definitely looks electroplated. I know they've got a flame spraying facility down there, but these definitely look like they're electroplated. So this is nickel silicon, Nicosil, and yeah, they've done a beautiful job of radiusing. Just putting a very small break edge on all the ports, done a lovely job of them, so I'm very happy with them. So now I've got my barrels back. Unfortunately you can't just slap them on the bike, stick the pistons in, off you go, because I think I may have mentioned it before, also they match, so they'll put a number. So there's a number on the back of my barrel, so we've got A and B. So just to keep your pistons, so what they'll do is they'll hone it to that piston to make sure the clearances are safe, just to match everything. So what I may have mentioned in a previous video, I think the last one, we talked about pistons, and this piston crown is a bit higher than the standard KR1s. Standard KR1s is fairly flat, got a very slight radius on it. and that's got a higher dome on it. So the problem you have is if you put a standard head on that, you won't have enough volume in the head. Your compression will be way too high, and from who I've spoken to, lots of people have done this before. These engines don't like high compression for good reason, because once they start getting into power band, you've got shitloads more fuel being pushed back up the exhaust into the combustion chamber. If you have too high compression, you start getting detonation issues around the edge of the piston. So we do not want high compression ratios, like stupidly high anyway. So what I had to do is I've had to measure the crown of that piston. So there's a few ways you do that. The way I do it is I put it on my surface table and put basically two bits of welding wire of a known diameter under either side. So where they all touch, so that's on the surface, then you've got two rods. So you can now work out what that radius is by where it touches those rods, just by measuring the gap. And the way I do that is I do it in CAD, because I cheat and I can't be asked to work it out mathematically, because the CAD does it for me. First thing I did is I drew the piston, then I drew the squish band that I wanted, which is about 0.75, worked out what angle I needed to cut in the head, and then the rest I needed to create a dome in the cylinder head which was at the correct volume. And the correct volume that I'm shooting for is, once it's all clamped together, pistons at top dead centre, you fill it up to the top of the spark plug hole, and I've been told it's 13 cc's that I should be aiming for. That's what they use on the RGV 300 conversion, so it's a 61mm diameter piston. We're in the right sort of ballpark. So I had to work out in my Etch a Sketch. So what that is the volume, so the space basically above the piston and to the top of the spark plug hole. Now, because I've drawn that as a solid, I can now just select properties and it'll tell me what the volume of that is. So it's easy, isn't it? You don't have to work anything out. It's simple. So if we go to my sketch, and I'll sort of try and explain how we got there. So on my sketch, you're limited. What I didn't want to do is cut this radius too deep and start cutting into the plug thread. You start doing that, you're going to have to start spacing your plugs back. So I tried to keep it in a smoothest, a radius that I can handle, but also trying to keep a squish band sensible as well. So this is where we got. So basically what you do is you draw half of that profile, and then you just tell it it's a solid. It will create that shape for you. So once you've got that shape, like I say, so that's our volume. So this is the space that we're trying to measure, and again, this is all theoretical, so you don't want to be, this is just where we're going to start. So once we've worked out roughly what radius we want, we'll cut it, we'll bolt it on the bike, and then we'll test it and see where we are. We may have to take a bit more off. So yeah, if you go on component properties down here, so under physical, you can see that number there. It's in cubic millimeters, but basically to convert that to cc's, you move that decimal point over one. So it's 12.73 cc's, which is where we're at. So that's pretty close. So from that, I know what angle I need to cut. I know what this measurement is. So this is the profile I need to cut in the head. So that's what we've done. And again, this is why you work it out in theory, do it in practice, and then tweak it. So that's always good if you've got a spare. I've got a few of these. So yeah, the first one I cut the squish band into the head. Also done the radius to what I'd worked it out to. But the problem I had with this side, this one is correct. So I've reduced this step on this side. The problem I had with this one is I need to pack the cylinder up a little bit because the port timing's slightly out. Because we've bored the cylinder out, it's changed the port heights slightly. Not by a lot, but it has changed them. So what that means is that I needed to get some spacers cut for the bottom of the barrels, just to play around and get that height, get the barrel height so the port timing is as good and close to standard as possible. If you raise the exhaust port too high, it becomes really peaky. If it's too low, it becomes torquey bottom end but it won't rev out. So I wanted it to keep it in pretty much around the standard port timing. So to do that, we have to lift the barrel slightly, but by doing that, the piston effectively drops in the cylinder. So because I cut this one to what I'd drawn, and you measure the squish band, or you measure the squish height, the squish height was massive. So what I've found is that I had to bring this whole lot down lower, so that's why this one's less. And when I stuck this on and measured it, that's the squish band that I want, with the correct spacer on the bottom. So the spacers are literally like the same as a base gasket, and I got three different thicknesses cut. So I get loads of laser cutting done, so I tacked them onto one of my orders. So I got a 0.5, I got 1mm and a 1.5 spacer. So what that enabled me to do is to be able to lift the, or put the barrel where I want it to make the port timing correct. So that's what I did, and what I found was I'm going to use a 1mm spacer on the base. So a 1mm spacer will go on the bottom end like that, and I will probably just glue that on. I won't be using a gasket either side. I'll use a flange sealant on that. Also, when my dowels are in, I'll blend this so it's exact matching to the crankcase. It's not far off now as it is. But what that does is that gets our barrel, just carefully put that in there. So what that does is when the piston and everything's in there, that gives us, I've got my degree wheel on here as well, so that puts my piston in the right degree range from when we're timing. We're trying to get the port timing correct, and this is why I've left the old piston in this side, so I can put a standard barrel straight on there and I can measure the port timing angle. So I've scribbled them down on a sheet of paper, and with a 1mm spacer on the base, we're pretty much the same as standard port timing, so we should be good for that. And so I measured the squish, decided that I'm going to use a 1mm spacer because of the port timing, and found that I needed to make it a little shallower on the initial machining of the head to get that right. So that's what I've done. I'm trying to find my head, my proper head. Oh, it's just here, look. Not done tonight. So this is one of the heads that I've, or another head that I've got, and which I've machined. The beauty of this bike is that the head is symmetrical, so that's exactly the same as that. So when I was setting up on this one, you can bolt the head on like this. So I cut one side and realised, oh, it's too deep. So I machined the other side and just bolted the head on like that and measured the squish, and it was bang on. So that's the beauty of it. It doesn't matter, you know, what side, because internally they're identical. You could, you know, it's the same head. So going from that one, our prototype, I've cut these. I've cut that radius, done it on my lathe. I'll show you my magic tool. So this is top secret. You mustn't tell anybody. For God's sake, don't put it on the internet what it is. But I'm only going to show you, alright? Huh? It's magic that, isn't it? Impressed, aren't you? So you can roughly set your tool centre. So from the tip to the centre line of that, to whatever radius you've worked out. Put it in your lathe, spin your head up, and just carefully roundy like that. So the squish band is just an angle cut using the compound slide. That's 14 degrees if anybody cares. So you cut that at 14 degrees. So that's tapering slightly away from the piston. So it's tighter at the sides, a little bit less in the middle. But that's really what I worked out on the drawing. So you cut that, and then you cut your radius. You bolt everything down with a modified head gasket. You fill it up. So I had to put the piston in there, put some grease around that to seal the piston, because you don't want your fluid running past it. So just put some grease around that with your piston in, put your head gasket on, bolt everything down. Doesn't have to be silly tight, just, you know, just nip everything up, and then you can actually measure the volume in the cylinder or in the combustion chamber. And the way I do that is my Breaking Bad laboratory equipment. You have to cut that bit and just edit the real bit that I said. So back in the day when I used to make biodiesel, I bought a load of stuff to do titration measurements, and so this is 5 cc's to that line. So what I use, yeah, back from the old biodiesel days, I've got a bit of methanol here. You want something that's not got a lot of surface tension, so you can use petrol, but that stinks, goes everywhere. So yeah, basically bolt your head on, fill it up 5 millilitres at a time. So you know, theoretically we should be around 13 cc's we're looking for, so you can put 10 straight in there, and then the last few cc's you just slowly fill it up, and then you just read off here where you are, and take my word for it, I was a cc out the first time I'd done it, which is a mile really. So I put it back in the lathe, changed the radius slightly, made the radius a bit smaller, but went in a bit further, so it creates a bigger volume in the head. If you think about it, if your radius is bigger, it makes it flatter. So you want a smaller radius, makes it tighter, makes a bigger area. So it took me a couple of goes to get that volume right, but we are pretty much bang on 13 cc's to the top of that plug hole. So that's where we're at. So the head is now modified. I've got both barrels, they look amazing. I've got both pistons, so everything's sort of ready now to be put back together. So that hopefully will be in the next video. I know it's a lot of talking in this one, not much machining, and the problem with the machining part of it, I've only got a little lathe, and I had to take the gap bit out. So taking the gap out of the lathe is a proper ball ache. Everything's got to be spotless. So you basically take this bit out, because when you spin up the head using the adapter that I made, so that goes in the plug hole. Let me get the head. So I turned up a threaded adapter. You can use an old spark plug, cut a spark plug up. Yeah, my lathe at home, or in this workshop in my shed, is quite small. You can put it on a faceplate, but you still have the same problem. The problem is it don't spin very far because the bed's in the way. So the way you get around that is you take this gap out. This is called gap bed load. So you take that gap out. That allows that to spin. I'll insert a picture here. So yeah, this is the problem I had. So that's how you spin it up and turn the head. So yeah, thanks for sticking with it. Weather's getting better, so I'm keen to get the old girl back on the road. It's a bit sad seeing it there, so it won't be too long. Once I'm happy that my calculations are right, I will be putting this back together with starting with standard carbs on it. But I've been talking to Bernie Campbell, who's a top bloke. He has a wealth of knowledge on these. He's been pointing me in all sorts of directions, which is really helpful. So he's sent me a link to a set of, I think, well, they're copy carbs, but I've had some cheap carbs before, and they were absolute shit. I couldn't get them set up. They were just a nightmare. I tried everything, needles, jets, everything. I just couldn't get them to work. And they were supplied by a fairly reputable bike tuning place. I won't name them, but I could never get it to run right. Put the standard cars back on it run lovely. So, but Bernie runs a set on his, and they are, you know, he's getting good power, and they seem really good. So I've gone for a set of those. So once they turn up, I'll get this running on the standard carbs first. Run it in probably for, I don't know, 5 minutes, and then yeah, we'll go out for a thrash, and then I can tell you what it's like having a 300cc KR1s. I am really looking forward to having it done, and maybe get it on the dyno once these other carbs turn up, see what we can get out of it. I'm not tuning it. I'm definitely not tuning it for power. Definitely not. Definitely not. It's for reliability. Yeah, right. So yeah, thanks for watching. If you like my drivelling on about crap, then hit that like button and subscribe if you can be asked.